All right, mathletes, we're talking about congruence in overlapping triangles. And this is section 4.7. This is our last lesson in this chapter. And so here, in this situation, we have two triangles, right? We have triangle ADE and we have triangle ABC. And one thing that I like to do, and something I recommend, is when you have overlapping triangles or any kind of overlapping figures, it's good to sometimes kind of take them apart and draw them separately. So then you kind of avoid the clutter and you can see kind of the individual components a little more clearly. So, so here we're given that AB is congruent to AC. So write that in here. So side AB is congruent to side AC. So AB, AC. All right. And we can see that angle B, and let me put given here. Angle B is congruent to angle 2. So angle B and angle 2. All right, let me do it over here as well. Angle 2 is angle E there. Okay, and then we can see that angle C is congruent with angle 1. So angle C and angle 1. All right. So those are the givens. So when we're trying to prove that triangle ADE, this triangle here, is isosceles. So for it to be isosceles, that means that angle A has to be congruent with angle ADE, right? Or angle A is congruent with angle AED, or what seems to be the more likely scenario, angle ADE is congruent with angle AED, right? So one of those has to be true for it to be isosceles, right? Two of these sides here have to be congruent. So since we have an isosceles triangle here, right? Since AB is congruent to AC given, we can say that angle B here, right? So angle B must be congruent with angle C, right? Because those are the base angles. So I can say angle B must be congruent with angle C, right? Isosceles triangle theorem. All right. And if that's the case, we have some transitive property that we can use, right? So we have B is congruent with C, and B and C are each congruent to different things. So if B is congruent to C, that means 2 is congruent to C, right? And if 2 is congruent to C, then 2 is congruent to 1. So we can say that angle 2 is congruent to angle 1. All right, by transitive property. Okay. So now we have this, right? We have, let me see here. So this angle is congruent with this angle, right? And that's almost enough to say it's isosceles, right? So now we can say, okay, well, if the base angles are the same, that means their opposite sides must be the same, right? So AE must be congruent with AD. And that's by the converse of the isosceles triangle theorem. Okay. All right, and now that we have that, we can say that since these are congruent, that means that triangle ADE must be isosceles, right? And we can say that by definition of isosceles. All right. So one thing I just realized that I had the wrong. I was a step behind where I needed to be. Right, like the saying that these angles are the same gets us to the doorstep of saying it's isosceles. Right. Really, what I need to prove for isosceles is that two sides are congruent. Right. So I should have been mentioning side AE and AD, or AE and DE, or DE and AD, right? So one of those three pairs had to be congruent.